Okay, what we're going to do is take another look at reactions, and in this vodcast it's going to be primarily practicing writing these reactions. Now, the reactants will be given for you and the products will also be given for you. These problems are coming right out of your work packet, and I believe we're starting on the bottom of page 2. So let's take a look at a couple of these reactions, and we'll go through some of them. Alright, so all you're basically doing here is writing the formulas for the reactants and the products and then balancing these equations. So I'm just going to kind of go through these, talk a little bit about each reaction, but primarily just go through them. So this should probably be a fairly short vodcast. Okay, hydrogen gas reacts with iodine. So the first thing you want to remember that hydrogen is a diatomic, so you put a subscript of 2 behind the hydrogen. Reacts with, remember that's the positive sign, and iodine also being a diatomic, so it gets a subscript of 2. To produce, that means that's where we put the arrow, and then hydroiodic acid, hydro being H, and then the iodic acid being I. So what you're doing is writing these formulas based on what we learned about writing formulas. Next thing you want to do is balance this one. So since we have 2 hydrogens in the reactant side, we want 2 hydrogens on the product side, so we're going to put a 2 in front of the formula HI, and so we'll have 2 hydrogens and 2 iodines, 2 hydrogens and 2 iodines. Alright, let's take a look at number 11. We have sulfur reacting with oxygen. Now sulfur is not diatomic, oxygen is. It's producing sulfur dioxide. Remember, when we use prefixes, that's with 2 nonmetals, so di being 2, so we have sulfur dioxide. We're going to balance this one. 1 sulfur, 2 oxygens, and 2 oxygens. So this one balances without having to add anything to it. Okay, let's move on and talk about the next couple. Calcium acetate. We've got calcium. The polyatomic acetate is C2H3O2, and since we're going to have to put a subscript behind it because calcium is 2+, that 2 has to go behind the parentheses. It's reacting with sodium carbonate, Na2CO3, and it's going to produce calcium carbonate. Remember, carbonate is 2-, calcium 2+, and it's going to form sodium acetate, C2H3O2. So when we go to balance this one, what you can do is treat the polyatomic like 1 unit. So in other words, we have 2 acetates, so we can put a 2 in front of this compound, so we have 2 acetates. We've got 2 sodiums, 1 carbonate, and 1 calcium. So that one balances. The next one says write the chemical reaction that shows how rust forms, rust being iron 3 oxide. So if that is going to be our product, remember iron 3 means iron with a 3+ charge, oxygen is 2-. What we're doing is writing the reaction to show how this compound is formed, and it's made out of iron and oxygen, oxygen being diatomic. So we're going to balance this one, and here we've got that oxygen 2:3 ratio. So if you remember, we put the 3 in front of the oxygen, a 2 in front of the iron oxide to make that 6 oxygens and 6 oxygens. And then we just need to balance the irons. 2 and 2 is 4, so we have 4 irons on the left side. Let's take a look at a couple more. Okay, let's take a look at number 14. We've got iron combining with oxygen and water, so we have iron combining with oxygen and water, and that's forming iron 3 hydroxide. So again, iron 3 is iron with a 3+ charge, so we have our formula here. Now this one's a little bit tricky And what you're going to find is you're going to try a couple different scenarios and they're not going to work. So if you notice, you've got your oxygens here in two places and the oxygen here in one place. So we've got to figure out a way to get the oxygens to be equal on both sides. So you're going to try a couple different numbers, and what you'll find is if you put a 4 here, that's going to give you 12 oxygens. So to make this side have 12 oxygens, the first thing you want to notice is that you've also got 12 hydrogens. So if you put a 6 in front of the water, that'll give us 6 oxygens. If we put a 3 there, that'll be 6 more oxygens, and that'll balance our oxygens and hydrogens. And then we can just put a 4 in front of the iron. And again, that one's probably the trickiest one on the paper. Okay, 15 says sulfur trioxide is bubbled through water, which means it reacts with water, and it's going to produce sulfuric acid. So we can balance the sulfurs, 1 and 1, the hydrogens, 2 and 2, and the oxygens, we have a total of 4 and 4. So that one again balances without having to add anything. Alright, let's look at number 16. You've got copper metal is made by treating copper ore the following way. You've got copper 2 sulfide is heated with carbon and oxygen to produce. So then the products for this reaction are going to be, let me get a pen, are going to be copper and sulfur dioxide and carbon dioxide. So when we go to balance this one, we've got 1 copper, 1 copper, 1 sulfur, 1 sulfur, 1 carbon, 1 carbon, and this one also balances without having to do anything. Let's look at 17. You've got copper bottom cooking pans turn black because copper combines with oxygen. So copper plus oxygen yields copper 2 oxide. So we can balance our oxygens first. We've got 2. We need 2 over there, so we'll put a 2 in front of our copper oxide. And then we'll balance the coppers. Okay, I think we have one last one on this podcast. We've got magnesium hydroxide. And again, hydroxide is 1 minus, so our formula will be MgOH2 is going to react with hydrochloric acid to produce magnesium chloride and water. Okay, so let's balance our magnesiums. We've got 1 and 1. Our hydrogens, we've got, actually, why don't we balance the chlorides, because those look like they'll give us a hint. So if we've got 2 chlorides here, we can put a 2 there to balance the chlorides. Now we can balance our hydrogens. We've got 2 and 2 is 4, so if we put a 2 in front of the water, that should do it, because now we also have 2 oxygens and 2 oxygens. So as you can see, balancing reactions is fairly simple. You will run into some more complicated ones like our iron and oxygen one here. That might take a little bit of work. One thing you do want to remember is you always want to balance and have the coefficients be in the lowest whole number ratio possible. We'll cover predicting products in the next podcast.